Hi everyone, I am Dr.S.SURYA, Assistant Professor, Department of Chemistry, A.D.M. College for Women, NAGAPATTINAM. Today we are going to learn about photochemistry for first semester. Introduction to photochemistry. Photochemistry is a study of chemical process that occur as a result of the absorption of light. It explores the changes in molecular and atomic structure that take place upon exposure to electromagnetic radiation. The photochemical reaction play a crucial role in various fields including environmental science, medicine and industrial process. Understanding the principles and mechanism underlying the photochemistry is essential for potential in offering different applications. In photochemistry, the branch of chemistry that explore the chemical process and reaction initiated or influenced by light. The fundamental concept underlying photochemistry is that light, composed of photons, can interact with matter and induce changes in electronic structure of the molecule. These changes can lead to a variety of chemical transformation, ranging from simple reaction to complex and highly specific process. Here, an introduction to the key aspect of photochemistry, the light absorption and electronic excitation. At the core of photochemistry is the interaction between the molecule and light. When a molecule absorbs light, typically in the ultraviolet or visible region of the electromagnetic spectrum, electrons within the molecule are promoted to higher energy level, resulting in electronic excitation. Photophysical process. The following electronic excitation molecule can undergo various photophysical processes such as fluorescence, phosphorescence or internal conversion, where excess energy is dissipated as light or heat. These processes play a crucial role in determining the fate of the excited state. Then photochemical reaction is formed during electron excitation can participate in photochemical reaction. These reactions are specific to the excited state and may involve bond breaking or bond forming or isomerization of process. Photochemical reactions are often distinct from thermally activated reactions. The basic principle of photochemical reaction we can see one by one: molecular excitation, quantum yield and stimulated emission. The molecular excitation refers to the process in which a molecule absorbs energy and transition from the low energy state to a higher energy state. This phenomenon is crucial in various scientific fields including chemistry and physics. Here is a concise more than 5 mark question in the molecular excitation. Then definition of molecular excitation is the absorbing energy by a molecule causing it to move from a low energy state to a higher energy state. This process is characterized by the promotion of electrons to higher energy level or changes in molecular vibration and rotation. The mechanism of molecular excitation, it typically occurs when the molecule interact with external energy sources such as photon or the light, heat or electric field. For example, when a molecule absorbs the photon with the energy matching the energy difference between ground state and excited state, it undergo excitation. Then energy level, the molecule have distinct energy level often quantized due to the quantized nature of electron orbit and molecular vibrational and rotational modes. Excitation involves the transition of electrons or changes in these modes to higher energy level. Then application, molecular excitation in fundamental in various applications such as spectroscopy, spectroscopic technique like UV, visible infrared and nuclear magnetic resonance, that means NMR spectroscopy, on the measurement of the energy absorbed during molecular excitation to obtain valuable information about molecular structure, composition and interaction. Then understanding molecular excitation is crucial in fields like chemistry, biochemistry and material science. It helps scientists comprehend the behavior of molecule under different conditions, leading to the development of new materials, pharmaceuticals and techniques. Additionally, studying molecular excitation aids in elucidating chemical reaction and the dynamics of molecular systems. Then the quantum yield is a parameter used to describe the efficiency of the particular process in the context of quantum mechanics. Specifically, in the photochemistry and photophysics, quantum yield is often associated with the efficiency of light-induced process. Here the brief explanation. The quantum yield denoted by the symbol of phi is a dimensionless parameter that represents the efficiency of particular photochemical or photophysical process. The quantum ratio of the number of events such as the emission of photon or a chemical reaction to the number of observed photon. Then range of values, quantum yield values ranges from 0 to 1. A quantum yield of 1 indicates that every observed proton results in the desired event, while a quantum yield 0 suggests no such event occur upon photon absorption. The importance of quantum yield is crucial in understanding and optimizing various processes, especially the study of photochemical reaction. It provides insight into the efficiency of light-induced process, helping researchers and scientists assess the practically and effectiveness of the given reaction or material in and light energy. For example, the associated quantum yield include fluorescence in molecular system, chemical reaction initiated by light, and photoelectric effect in material. Different processes and materials may have varying quantum yield, and understanding these values is essential for applications such as solar energy conversion and the development of light emitting devices. Stimulated emission is a fundamental process in quantum mechanics. It's a major role in photochemistry. It's a crucial role in the functioning of laser. Here, concise 5-mark question, the stimulated emission. Then define of stimulated emission is the quantum process in which an excited atom or molecule already in an excited state undergo a transition to the low energy state by emitting a photon. Importantly, the emission is triggeringly by the presence of external photon of the same frequency known as the stimulating photon. Then Einstein coefficient is described by emission, stimulated emission. The coefficient represents the probability per unit time per unit volume of a stimulated emission event. Stimulated photon emission when a photon of the right frequency is present. The population inversion achieves stimulated emission efficiently. The population inversion is required. This condition occurs when more atom or molecule are in excited state than the lower energy state. Achieving population inversion is a crucial or critical step in the development of laser system. The role in laser operation. The stimulated emission is the key process that amplifies light in laser. In a laser, a gate medium is used to achieve population inversion. When a photon passes through the medium, it stimulates the emission in an identical photon. It leads to the light process resulting in coherent and amplified light emission. Then application of stimulated emission has a numerous practical applications. Primarily in the field of laser, laser find applications in various fields such as communication, medicine, industry and research. They are used for tasks ranging from precise cutting and welding to medical surgery and scientific research experiments. Highlighting the importance of stimulated emission is a modern technology. The absorbing light and electronic transition is the important one, chromophore, and second one singular and triplet state, and third electronic excitation. The chromophore play a significant role in absorbing light and reflecting light in various biological and chemical systems. Here, concise 5-mark question is the important. The define the chromophore is a molecular structure or group of atoms within a molecule that is responsible for the absorption of light, resulting in the color. Chromophore are crucial component in the coloration of compound and materials. The chemical structure of chromophore is often containing conjugated system of double bond or alternating single or multiple bonds. This extended system allows for the absorption of light energy, promoting electron to high energy level and causing the molecule to appear colored compound. Then role in pigment. Chromophore are internal to the coloration of pigment in biological system. For example, chlorophyll is a green pigment in plant responsible for the photosynthesis, containing a purple ring as a chromophore. A specific arrangement of atom within this ring allowed to chlorophyll to absorb light efficiently. Then spectroscopic application. Chromophore are widely used in spectroscopy to study molecular structure and interaction. Then UV visible spectrum in particular relies on the absorption property of chromophore to provide information about the electronic structure of the molecule. Then environmental and biological significance of chromophore have environmental and biological significance in environmental science and presence of specific chromophore. in water bodies can indicate the presence of pollutant. In biological system, chromophore are found in various biomolecules such as pigment, dye and fluorescent proteins, contributing to the diverse colors observed in living organisms and facilitating processes like vision and photosynthesis. What is the triplet excited state? The triplet excited is more stable than the singlet state because it has a more unpaired electron. The triplet state has 3 unpaired electrons, while the singlet state only has 1 unpaired electron. So, the triplet state is also lower in energy than the singlet state. What are the singlet excited state and the triplet state? When the electron is excited from a ground state to an excited state, it can exist as either a singlet or triplet. In a triplet state, the spin of the 2 electrons are antiparallel, then they maintain the spin configuration even when the electrons are on the different orbital. In a singlet state, the spin of 2 electrons are parallel and they can have different orbital configuration. Then singlet excited state, triplet excited difference. The main difference between the singlet and triplet state is that the triplet state is more stable than the singlet state. This is because triplet state have 2 unpaired electrons, while singlet state only 1 unpaired electron. The triplet state is also higher in energy than the singlet state. The triplet state is about 33 kilojoule per mole higher energy than the singlet state. The difference in energy afford the carbon because it makes the triplet state more stable than the singlet state. The excited state and relaxation process, excitation, relaxation and phosphorescence. The excited state and relaxation process are fundamental concepts in physics and chemistry that describe the temporary increase in energy of atom or molecule and the subsequent return to lower energy state. Here, excited state refer to the higher energy state that an atom, molecule or particle occupy when it absorbs energy. This absorption can occur through various means such as exposure to light or heat. In the excited state, the electron may be promoted to higher energy level and the system is less stable in the ground state. The excitation, electronic excitation is a common from the excitation where electron absorb energy and move to higher energy orbital. This process is often associated with the absorption of photon, leading to the promotion of electron from lower to higher energy level. Then vibrational and rotational excitation can also undergo vibrational rotational excitation. Vibrational excitation involves increase in the vibration energy of atom within a molecule, while rotational excitation involves increase in the rotational energy of the molecule. Then the relaxation process, after being excited the molecule, the system tends to return to the lower energy state, the process known as the relaxation. During relaxation, the excess energy is typically released, often in the form of photon, then heat or through collision with other particles. The relaxation process is crucial for maintaining the stability and equilibrium of the system. Spontaneous emission and non-radiative process. The relaxation process may involve spontaneous emission of photon, where the excited electron spontaneously falls back to the lower energy state, emitting a photon. Alternatively, the non-radioactive process can occur, where the excess energy is transferred to the surrounding with the emission of photon, such as through collision with other molecules. In photochemistry, the dissociation process refers to the breaking of chemical bond within a molecule under the influence of light. This process can result in the formation of fragments or product with different properties compared to the original molecule. Here the concise make answer the dissociation process in the photochemistry. Then definition of dissociation in photochemistry is referred to the cleavage of chemical bond within a molecule induced by the absorption of light energy. This process can lead to the generation of fragment or product, often with distinct chemical and physical property. Then the absorption of photons, dissociation process begin with the absorption of photon, the target molecule. These photons typically have energy matching the electronic transition of the molecule, the promoting the electron to higher energy level and initiating the dissociation process. The electronic excitation. During the absorption of photon, the molecule undergo electronic excitation, leading to promotion of electron to higher energy level. This increased electronic energy can displace exciting chemical bonds, making the molecule prone to dissociate. Then bond cleavage and fragmentation. The increased energy level in the excited state can lead to the cleavage of chemical bond with a molecule. This bond cleavage results in the formation of fragments or product, which may exhibit different chemical or physical property compared to the original molecule. The specific bond broken depend on their molecular structure and the absorbed light energy. Then the application and significance. The dissociation process in photochemistry has significant application in various fields. For instance, it is exhibited in the photoreaction for studying reaction dynamic and mechanism. In atmospheric chemistry, the dissociation molecule such as ozone due to sunlight play a crucial role in environmental process. Additionally, dissociation reaction are integral to the design of photoavailable compound used in controlled drug release and other technological applications. Then photoisomerization, the process in which the structural arrangement of molecule undergo the change due to the absorption of light. Then definition of isomerization refers to the reversible transformation of a molecule from one isomeric form to another upon the absorption of light. This phenomenon is known as the photoisomerization. The mechanism. Photoisomerization involves the excitation of electron in a molecule to higher energy state upon absorption of light. This energy can induce conformational changes or rearrangement of bonds within the molecule. So, the excited molecule then undergo isomerization to a different structural form. The process is often reversible, meaning that isomers can revert to their original state under specific conditions. An example of photoisomerization is found in certain organic compounds such as azobenzene. In this transform, azobenzene absorb light and undergo isomerization to the cis form. This transformation can be reversed by exposing the cis form to specific condition, leading to revert back to the trans form. An application of photoisomerization has various applications in fields such as material science, biology, and photopharmacology. Then for instance, it is utilized in designing light responsive materials and drugs that can be controlled and activated by light, offering precise spectrophoral control in specific application. It seems like might be a slight confusion in the term of photosensitization. If you are referring to photosensitization, which is a process involving the absorbing of light by a photosensitizer to generate reactive species. I can provide the answer based on the understanding. If you intend a different term or concept, please, it's a define of photosensitization is a process in which the photosensitizer absorbs light energy and transfer into another molecule, leading to the photochemical reaction. The photosensitizer initiate or facilitate chemical reaction by generating reactive species upon light absorption. The mechanism of photosensitization is typically involve a photosensitizer molecule which absorb photon of specific wavelength, causing it to enter an excited state. In this excited state, the photosensitizer can transfer its energy to nearby molecule through various processes such as electron or energy transfer. This transfer of energy can result in the formation of reactive species like singlet oxygen, which can then participate in a chemical reaction. Then application of photosensitization has diverse applications, notably photodynamic therapy for medical treatment. The light activated photosensitizer are used to selectively destroy abnormal or cancerous cells. The photosensitizer is administered to the patient and accumulate in the target cell, which are then exposed to light, triggering the production of reactive oxygen species that induce cell death. The environmental implication. Photosensitization also relevant to environmental chemistry, where it can contribute to the degradation of pollutant. Photosensitizer in water or soil can absorb sunlight and produce reactive species that participate in the breakdown of organic pollutant, helping to migrate environmental contamination. The photosensitization involves the absorption of light by the photosensitizer, leading to the generation of reactive species and finding application areas like medical therapy and environmental remediation. The photocatalysis is a process in which catalysts activated by light accelerate the chemical reaction without being consumed in the process. Here, the definition of photocatalysis: the chemical process where a catalyst known as photocatalyst use light energy to initiate or accelerate the reaction by facilitating the conversion of reactant into product without undergoing any permanent changes itself. The mechanism of photocatalyst involves the semiconductor material as a photocatalyst. When exposed to light of appropriate energy, electron in the photocatalyst are excited to a higher energy state, creating electron hole pair. These change carrier participate in redox reaction where the electron reduce certain reactant and the hole oxidize others. These generate reactive species that drive a desired chemical transformation. Then application: photocatalysts find application in various fields including environmental remediation, water purification and organic synthesis. For example, the degradation of pollutant, photocatalysts can break down organic compound into harmless byproduct under the influence of light, contributing to the purification of air and water. Energy and sustainability: photocatalysts are of interest for its potential in sustainable energy production. In photocatalytic water splitting, for instance, light-induced reaction can be used to generate hydrogen from water, offering a clean and renewable energy source. This process has implication for the development of solar fuel and energy storage system. In summary, photocatalysts harness the power of light to drive chemical reaction efficiently, with application ranging from environmental cleanup to sustainable energy production. The ability of photocatalysts to operate under mild conditions and utilizing renewable energy sources make them promising tool for the addressing various challenges in chemistry and beyond. Then we can see application of photochemistry. The first one, photodynamic therapy in medicine. Photodynamic therapy involves use of photosensitizing agent which accumulate in target tissue or cell. When exposed to light of a specific wavelength, these agents generate reactive oxygen species, leading to localized cell damage or death. Then PDT is used in treatment of certain cancer, dermatological condition and microbial infection. Then photovoltaic cells, cogen generation. Description of photovoltaic cell converts sunlight into electricity by utilizing the photoelectric effect, where the photon from sunlight knock the electron loose from atom in the semiconductor materials. The solar cells are widely used for harm the solar energy to generate electricity for residential, commercial and industrial purpose. Then environmental cleanup through photocatalysts. Photocatalysts often based on semiconducting materials can break down pollutant in air and water when exposed to light, promoting the degradation of organic contaminants. Is employed for water purification, air pollution control and the removal of harmful organic substances from the environment. Then the photochemical synthesis in organic chemistry. The reaction are utilized in organic synthesis to create complex molecule by activating specific chemical bond under light irradiation. Then methods are employed to synthesize pharmaceutical, agrochemical and other specifically chemical in more efficient and environmentally friendly manner. Then photolithography in electronics and microfabrication is involved using light to transfer a photon onto the substrate, commonly the semiconductor industry for the fabrication of electronic compounds. It is a key process in the manufacture of microchips, integrated circuits and other electronic devices. The photochromic materials on optics and technology is a material changes color or optic property in response to light, making them useful in applications such as eyeglass, a smart window and sensor. The lenses adjust to varying light condition and photochromic coating are used in smart window that can dynamically control light transmission. The art, conversion and preservation. Light sensitive materials such as certain pigment and dye can undergo degradation over time when exposed to light. Understanding photochemistry is crucial for preserving artwork and cultural activity. These applications has a highlight of the diverse and impactful role of photochemistry in improving technology, medicine, energy and environmental sustainability. Thank you.